Today we're still looking at proportional relationships, but we're going to do what's called interpreting graphs. So we're going to look at information in graphs and be able to answer questions about the graph. Example 1, Grandma's special chocolate chip cookie recipe, which yields 4 dozen cookies, calls for 3 cups of flour. So we make 4 dozen cookies. It needs 3 cups of flour to do that. Using this information, complete the chart. So I'm going to be pausing the video some throughout this activity. Just to save some recording time. So the first part says create a table comparing the amount of flour used to the amount of cookies. So here's our table. Go ahead and copy that down, hit pause, and then we'll fill it in together. Here come our numbers. For 3 cups of flour, we know that that would yield, or that would produce 4 dozen cookies. Now I got to remember to put that our cookies are in dozens here. It doesn't mean 4 cookies, 4 dozen cookies. If that's true, then 6 cups of flour would give you twice as many dozen cookies, 8. And if we doubled it again and did 12 cups of flour, that would double our dozens again to 16. That just gives us some information to look at in a table. We chose the cups of flour. Chose them in multiples of 3 because that would be the easiest way to do it, considering 3 cups of flour makes 4 dozen. Let's look at the second part. Is the number of cookies proportional to the amount of flour used? Answer to that is yes. Reason being is that we have a constant ratio of 4/3 when we simplify the fractions, when we simplify the ratios. Third part, what is the unit rate of cookies to flour y/x? Well, and then it says, what is the meaning in the context of the problem? Well, our unit rate is 4/3. But if we write that as a mixed number, 3 goes into 4 one time, and then there would be 1 remaining. So 1 1/3 is our constant of proportionality. And what that means is 1 1/3 dozen cookies for every cup of flour. For each cup of flour. Now another thing we want to know is that a dozen cookies, 1 dozen, equals 12. So 1 1/3 dozen would be 12. And then 1/3 of 12. So if you divided 12 by 3, you would get 4. So 1 1/3 dozen is actually 16 cookies. So that would be another way to write this, 16 cookies for each cup of flour. Looking down to the graph, model the relationship on a graph. So we're going to set that graph up, and we're going to put on some ordered pairs. Okay, so record your graph the way you see mine. You'll have to pause to do that. And then we're going to add in the values from the table. So 3 cups of flour should produce 4 dozen cookies. So if I go down here and I go to 3 cups of flour, 1, 2, 3, and then I go up to 4 dozen cookies, 1, 2, 3, 4. Should have a point right there. Next in our table was 6 cups of flour to yield 8 dozen cookies. So again, on the y-axis, we're going to go to 6. We're going to go up to 8 and put another ordered pair. And lastly, 12 cups of flour should produce 16 dozen cookies. So we have 3 points there. We can connect our line, connect our dots with a line, and it should form a nice straight line through the origin. And if you look at 1, remember 1 cup of flour would produce 1 1/3 dozen cookies. If you look really carefully here at 1 would be right here. If we follow that up until we hit the line, and then you follow it over, you see that it's a little bit more than 1. 1 would be right here. So 1 cup of flour would produce a little more than 1 cup of cookies, or 1 dozen cookies, so it would be 1 1/3 dozen. We're going to explore a little more with those graphs and figuring out that information live here in class after the notes. Next spot is, does the graph show that two quantities being proportional to each other? Yes, it does, because it is a straight line through the origin. Last part on the front, we need to write an equation that can be used to represent the relationship. We're going to use D to stand for dozens of cookies. And to get our number of dozens, what we're going to do is multiply 1 1/3 times the cups of flour. And that'll work every time. We can try it out. If we had 6 cups of flour, we would put a 6 here in place of F, multiply it by 1 1/3, and it would give us the number of dozens, which if we look in our table would be 8, and 6 times 1 1/3 is 8. So our equation that will work every time is this. Okay, so I'm going to lead you through some of this example too, and some of it you will have to pause and work on your own. So this graph shows the sugar needed to make the cookies. It says record the coordinates from the graph. So there are, let's see, 1, 2, 3, 4, 5 different coordinates. I'm going to pick one and highlight it, kind of show you how this works, then you guys can do the others. This coordinate right here has an x value of 2. It has a y value of 1, 2, 3. So my ordered pair would be 2, 3. And it says what you guys are going to fill out the other ones. So you should have to do 1, 2, 3, 4 more. But it's going to ask us, what do these ordered pairs stand for? Well, 2 is my x value. So it stands for cups of sugar. 3 is my y value, so it stands for dozens of cookies. So what this really means is 2 cups of sugar for 3 dozen cookies. You need to put the other 4 ordered pairs down here in this space. Make sure that you show me those when you're done. Grandma has 1 remaining cup of sugar. How many dozen cookies will she be able to make? Plot the point on the graph. So that means we're going to go to 1 cup of sugar. So it's going to be 1 comma something. So if we go to 1 here, we're going to follow it up until it hits the line and then follow it over. And it looks like we would be right between 1 and 2. So our best guess there would probably be 1 comma 1.5. You can have decimals in these. And what would that mean? It would mean 1 cup of sugar would get you 1.5 dozen cookies. How many dozen cookies can Grandma make if she has no sugar? Can you graph this point on the coordinate plane provided above? Well, if she has no sugar, that's going to be right here, and it's going to be at the point 0, 0. So how many dozen cookies can she make? 0 dozen if she has no sugar. And you call that point the origin. All right, these exercises, number 1, A and B, I'm going to have you pause the video completely and try them both. Remember, read carefully, and then hit play to see the answers. So go ahead and hit pause. All right, letter A says, can you determine by looking at the graph whether the length of the shower is proportional to the number of gallons? So is time proportional to gallons? Yes, because we have a straight line through the origin. Part B, how long can a person shower with 15 gallons of water? So with 15 gallons of water, here's what I do. I go down here, I look at my gallons on the x-axis. I find 15. So if I zoom in, it looks like each interval here is counting by fives. 0, 5, 10, 15, 20. So 15 is right here. I'm going to follow that up until I hit the graphed line. Then follow it over on my y-axis and see that it is at 5. So that means that 15 gallons of water would be used in 5 minutes. So how long can a person shower on 15 gallons? 5 minutes. Then they ask us how long would 60 gallons of water last? We do the same thing. We find 60 on the graph, follow it up and then over, and 60 gallons would last 20 minutes. I'm going to do part C with you, and then I'm going to kind of read through the rest of this so you guys can complete the rest of your classwork in class, and then we'll take it from there. So part C says, what are the coordinates of point A? If we look at point A, it is at 30, 10. 30, 10. So we're going to write that down. 30, 10. And it says describe what it means in the context of this problem. Well, 30 is the x value. So if we look back at the table, our x value is gallons. Okay, so that means 30 gallons, and our y value is 10. On our label here on the y value, it says that it stands for minutes. So this means 30 gallons and 10 minutes. So what's that mean in the context of this problem where we're talking about a shower? It means you would burn 30 gallons of water. Well, not burn, you would use 30 gallons of water for a 10-minute shower. Okay, you're going to end up answering the rest of these questions, and you're going to call me over when you have it all done. The most challenging part is going to be part 2 here, number 2, where it says your friend uses the equation C equals 50 times P to find the total cost, C, so C stands for cost, for the number of people, P, entering a local amusement park. So it says create a table. So in your table, you're going to have cost, and you're going to have people. Where are you going to get the numbers from? You're going to make them up. Okay, so you can have a small number of people entering the park. You could have a large number of people. Let's make sure your table has about 3 columns in it. Okay. So it's because it says different sized group. So make sure you pick some different ones. And then it says, is the cost of admission proportional? What you're going to do is you're going to take your table and you're going to make ratios and simplify those to see if you can find a unit rate. And then last, you're going to graph that information. We can do that together as a class if you're struggling with that. Okay, so you're going to take your table and you're going to make ordered pairs out of it and then graph those ordered pairs. How are you going to find the information in your table? Well, remember, however many people you choose. So if you chose 10 people, you would plug that into the equation that is provided right here. Cost equals 50 times the people. So if I chose 10 people, that's 50 times 10. That's $500. So somewhere in my table, I would have, 10 people and $500. That would be one of the columns in my table. Go ahead and pause the video and take your time with the rest of these. Really call me over if you have questions, and let's really make sure we know how to read a graph.